Hi guys, Mr. Bennett here. Today we're just going to look at some examples of using potential kinetic energy and the law of conservation of energy, as well as we'll be doing some work to do with work. Alright, so hopefully it'll make sense after we've done this. So keeping in mind, we've already watched a video on potential energy. So if you think about the formulas, the first formula here is we've got our potential energy formula. Okay, that's equal to mgh. We measure that in joules, and the same thing is for kinetic energy is a half mv squared, and we also measure that in joules. Now, like any other conservation law, basically what we know is the law of conservation of energy says that you can't lose energy. All right. So what happens is that energy is not lost to the system; it just gets transformed from one form to the other. Right. Here's the first example we're going to look at. Let's say we've got a person at the top of a skateboard ramp, 100 kilograms. Right, this ramp is massive. Okay, it is 80 meters high. Right, so in terms of this jump he would do, so what sort of potential energy does this person have at the top? Well, if they weigh 100 kilograms, gravity is 9.8 meters per second squared, and then the height there, that means they've got 78,400 joules. Okay, so we can also put that in scientific notation. Now, at the top, they don't have any kinetic energy. Right? Now, at the bottom, what's going to happen is they've got no potential energy, but they're going to have that much kinetic energy, remembering it gets transformed from one form to the other. So therefore, we know kinetic energy is equal to half mv squared. We do know the mass, we just don't know the velocity. So if we put in the mass there, then what we can do is we can take this term here and we can bring it down to the bottom over there. Remember the rule of algebra? Okay, the very simple rule is when you're timesing and dividing, when you go across the equal sign, bottom goes to top, top goes to bottom. So here we got v squared is equal to that. To work out what v is, we have to take the square root of all that. So we might as well do that in one step. And so therefore that gives me a speed of 39.6 meters per second. Timesing that by 3.6 will give me 142.55 kilometers per hour. So that would be an ultimate rush, I would think, going on a skateboard. Right, second example. I know Mythbusters did this in a episode. So let's say we have an elevator, and the elevator is going to a height of 50 meters. Now, we're going to do a couple of things here. So the first thing we're going to do is going to work out the work required in order to take this up to the top of the shaft. Okay, so the work is equal to simply the force times by the distance. Right. So what do we know about the force? Well, the force is equal to mass times acceleration. So that's going to be equal to 2,000 kilograms. Now, in this particular case, we might use just 10 because it'll make life easier. That's gravity. Right, and then times by the distance, which is 50. Right, so therefore that's going to be 20,000 times by that, so that's going to be 110,000. It's 100,000, I think. 1, 2, 3, 4, 5. Okay, joules. 100,000 joules is what we're going to have in terms of our work. So the amount of work that you're going to need to use in order to take that to the top, now, is going to be equal to what potential energy it's going to have. So the potential energy is equal to mgh. Oh, really, that there is mg, and that's h. Okay, so the work required is in fact equal to our potential energy. So we know that's equal to 100,000 joules of energy. Now, the other way of writing that is write that as 10 to the 5 joules. Okay, because that's how many zeros we have there. Now, if for some reason at the top of the elevator that the cable broke and the elevator fell down. Now, the Mythbusters thing was that if you jump at the bottom, you can reduce the forces and hopefully survive the crash. Well, I don't think it's going to matter too much, really. Kinetic energy we know is equal to a half mv squared. Right, so at the top, the kinetic energy is equal to, well, it's equal to 0. But at the bottom, the kinetic energy is equal to whatever the potential energy is equal to, which is 10 to the 5 joules. Alright, so we know that. So therefore what we can say here is 10 to the 5, or 100,000 joules, is equal to a half the mass. Now the mass was 2,000 kilograms. That's the mass of all the people in the lift, times by the velocity squared. Right, so what's a half of 2,000? Well, we know that's going to be, let's write this as 100,000. Half of 2,000 is going to be 1,000 times by v squared. Now, because you're year 11, you can take some shortcuts. So I can cross this off over here with that because I'm going to divide it. Or I could say 100,000 divided by 1,000 is equal to v squared. Now, rather than writing this v squared, I know I'm going to take the square root of that. So that's going to be equal to the square root of v. So therefore v is going to be equal to the square root of 100, which is going to be equal to 10. Okay, that doesn't sound right to me. I think I might have made a mistake. I think that was supposed to be a million. Alright, so anyway, you get the concept. Okay, so that's going to be meters per second. So therefore that would be times by 3.36 kilometers per hour. I think it's supposed to be faster than that. So if we made that to the 6, make this over here to a million, the square root of 1,000, so let's go square root of 1,000 equals 31, and we times that by 3.6. That's going to be working out, that's a bit more realistic, isn't it? So that's going to be 31.6, and it's about 113 kilometers per hour. Right, so it's a process more than the actual answer I really care about. Okay, so that's the first example. Second example, if you go to Movie World or into the Gold Coast, or to the theme parks, they have a whole heap of rides, and certainly roller coaster rides are fantastic fun. But they've got one ride called the Giant Drop, and I think this one's at Dreamworld. So let's say we've got our Giant Drop. Okay, it's got a height of 80 metres, so therefore, and the mass of the actual thing with all the people is 5 tonne, which is 5,000 kilograms. Right, we can do the same sort of thing again. What sort of speed would you be hitting when you get to the bottom of this particular ride if you fall 80 metres? Okay, so to do that, first of all, we have to work out the potential energy or the work done required to take the people from the bottom to the top. We know it's going to be mgh. So therefore the mass is 5,000. We're going to have gravity, which is 10. Or we could use 9.8 if we wanted to. And then the height of that's 80 metres. Alright, so let's do a calculator. 5,000 times 10 times 80. So that's equal to 4 million joules. Okay, so easiest way to write that, obviously 4 million joules, is to write that as equal to 4 by 10 to the 6 joules. Okay, so that's our first answer. Now, we want to work out how fast this thing's going at the bottom, so we know that the kinetic energy at the bottom is going to be equal to 4 by 10 to the 6 joules. The potential energy at the bottom would be equal to 0 joules. Alright, now we could do the same sort of thing. Now, I'm going to do something slightly different. I could say to you, what is the kinetic energy halfway? So halfway, it's going to be 2 by 10 to the 6 joules, and the potential energy is equal to 2 by 10 to the 6 joules. Or if I wanted to work out any height, I could just work out what the potential energy was, and then the difference between the original potential energy and the one that you calculate is going to be the kinetic energy. So you could actually use that to find the speed at any point. So let's say if we want to work out how fast you're going halfway, well, we know that the kinetic energy is 2 by 10 to the 6. That's equal to a half of the mass. What's the mass? Well, the mass was 5 tonne, 5,000 kilograms times by the velocity squared. Again, I hope you see that we're doing the same thing every time. So that's going to be equal to 2,500. Z equal to v squared, and that's 2 by 10 to the 6. So therefore, the velocity is going to be equal to 2 by 10 to the 6. You have to divide that down over here, and then you have to take the square root. So you can do it in one step, right? So it's the same sort of mathematics we're doing the whole time. Now go to your calculator, we'll do that. So I'm just clear that. So it's the square root of, okay, so it's 2. Now you have to use this button here, E button, to the 6. Divide that by 2,500 and enter. And that's going to give me 28.28. Times that by 3.6. And that means I'm travelling 100 kilometres an hour, 101. Okay, so again, so that's 28.28 metres per second, which is equal to, oh, funny looking equal sign, 101 point something kilometres per hour. Alright, so that's the same sort of concept we're doing here. Just going to do a very quick example here. Let's say we work the opposite. Let's say you've got kinetic energy at the bottom and we want to work out how high you're going at the top. So another fantastic ride. And if you ever go up to the Gold Coast, you need to go and do this one. It's called the Terra. We know that this one here, you start off very fast and you go up this particular ramp. You go up there, and then when you get to a point where gravity stops you, then you come back this direction here. Alright, it's a really cool ride. Let's say you're going initially at 200 kilometers an hour. Now 200 divided that by 3.6, and that's going to give you 55.56 meters per second. So 55. Remember, you have to be working in SI units. That's really important that you do this. Okay, we have to work out the original kinetic energy. That's going to be a half mv squared. So that's equal to half of the mass. Now the mass of the thing is 4 tonne, and you've got a velocity of 55.56 squared. So this is what we've got to do in our calculator. So 0.5 times by the mass, which is 4 tonne, mistake, times by 55.56 squared. And that's going to give me 6,173,827. I probably won't remember that. 6,173,000. I have to go back. 827.2. 827.2. You might want to say that's equal to 1.74 by 10 to the 6 joules. Okay, you can round that off. So that's my kinetic energy of the system. Now what's going to happen is I want to work out how high I need to make this tower. If I'm launching my people at that sort of speed with that much energy, I need to make sure that they're not going to go through the roof. Alright, so I need to make sure how high do I need to make my tower. Well, I know that my kinetic energy at the top is going to be equal to 0. I know my potential energy at the top is going to be equal to 6.74 by 10 to the 6 joules. Okay, so I know all that's been converted to that at the top, right? Now we know what potential energy is, so we've got 6.174 by 10 to the 6, that's at the top, is equal to mgh. Now we do know gravity and we do know the mass. Let's use 9.8 for gravity this time. So therefore, we know that our height is simply going to be equal to 6.174 times 10 to the 6 divided by m divided by that. So I've got to go, remember it was 4 tonne, and that's going to be times by 9.8. Now I've already got that in my calculator, so if I just go to my answer and I go divide by, and now I have to put this in a bracket because we've got two terms, so 4,000 times by 9.8, and that's equal to 157.4 157.5 meters. Okay, so that means equal to 157.5 meters. So you might say, just for tolerance, you might have to make the 160, probably 170 meters to make sure that people aren't going to go over the top. And if I didn't want to make it 170 meters at the top, what I need to do is I need to change that speed that it hits the bottom of the ramp with. If I make that a little bit smaller, then that will actually change how high I need to make the ramp up the tower, because that's quite a tall tower to make. What you would do for this ride is you'd make the acceleration to a lower speed greater, and that would make the ride feel really cool, but also you won't be doing 200 k's, you might be only doing 160 k's, therefore you don't have to make it quite as tall. Now I hope these examples are useful for you in terms of answering your tutorial questions, getting a key idea that you transform one thing to the next thing. So whether you're working in potential energy, kinetic energy or work, we know that those things are all very similar to each other. Okay, they're just transformations of energy. So good luck with your tutorial questions. Make sure you catch up with me if you need some help.